In this video, we're going to look at questions and one more question from exercise 13.E. Question number 6. It says find the coordinates of the foot of the perpendicular from the point 30 minus 1 to the line with parametric equations given to you here. I'm going to draw this first. So we have a line like that and a point here, the point from where you need to draw the perpendicular and find the foot of the perpendicular. When you look at the equation of the line, the coefficients of the parameter, that's t, will give you the direction vector. So the coefficients are 3 here, 2 here and 1 here. So 3, 2, 1 gives you the direction vector, a vector parallel to the given line. So I mark a vector which is parallel to the given line, which is 3, 2, 1. Now what we are going to do is we draw a perpendicular from P to the given line, and a perpendicular meets the line at Q. So Q is the foot of the perpendicular. I'm going to start with the equation of the line one more time. So I copy the equation of the line, and I know that when an equation is written like that, it actually represents any general point on the line. As I choose different values for t, I get different points on the line. So this is any general point on the line. And if it is any general point on the line, now we are going to say that let it be q. So I'll say let q be this point for some value of t. So that's what I say here. So q is this point, and for what particular value of t we need to find. So at the moment we'll say let it be q for some value of t. What we are going to do now is we find what is vector pq. And what's vector pq? Vector pq is position vector of the terminal point minus position vector of the initial point, which is OQ minus OP. I know what is OQ vector. Q point is known to you, so I write my OQ vector 2 plus 3t minus 2 minus 1 plus 2t 4 plus t minus OP vector, and P is 3 0 minus 1, so OP vector is 3 0 minus 1, like that. And then to subtract, I subtract the corresponding term. So 2 plus 3t minus 3. 2 minus 3 is minus 1. So minus 1 plus 3t. Minus 1 minus 0. So that's minus 1 plus 2t. 4 plus t minus minus 1. Minus minus makes it plus 1. So 5 plus t. So that's my PQ vector. Now what is special about PQ? PQ is perpendicular on the line. So PQ is perpendicular to B vector. If PQ is perpendicular to B vector, PQ vector and B vector are perpendicular, their dot product has to be equal to 0. So I say PQ is perpendicular to B, therefore PQ dot B is equal to 0. So I'll write my PQ vector dot the B vector has to be equal to 0. So I'm copying my PQ vector dot the B vector is equal to 0. Now how do you take the dot product? We multiply the I coefficients together, plus we multiply the j coefficients together, plus we multiply the k coefficients together, which means 3 times minus 1 plus 3t plus 2 times minus 1 plus 2t plus 1 time 5 plus t. So this is equal to 0, which implies, so that's the dot product is equal to 0. Then I try to open the bracket and simplify. So minus 3 plus 9t, here minus 2 plus 4t, and then 5 plus t. So I add up all the t terms together, which gives me 14t, and the numbers get cancelled. You could check it, minus 3 and minus 2 is minus 5 and plus 5 cancels. So 14t is 0, therefore t is equal to 0. That's what we got. So now we can find out the foot of the perpendicular Q, and Q will be, I go to the point Q and replace t by 0. So I'll get 2 plus 0 minus 1 plus 0 and 4 plus 0. So 2 minus 1, 4 is the foot of the perpendicular. Moving on to the B part, the question is to find out the shortest distance. Shortest distance is the perpendicular distance, which is PQ. And PQ is root of root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. X1 y1 is z1 is p3 0 minus 1 and x2 y2 z2 is this point q 2 minus 1 4. So I do x2 minus x1 3 minus 2 the whole square plus y2 minus y1 0 minus minus 1 0 minus minus 1 the whole square plus z2 minus z1 minus 1 minus 4 the whole square. So that's going to be 1 square is 1, 1 square is 1 and 5 negative 5 square is 25 which is root of 27. That's 3 root 3. One more question of the same thing, same type. It says find the same question. It is find the coordinates of the foot of the perpendicular drawn from this point to this line. So this is like r vector is equal to a vector plus t times b vector. So my b vector is already given to me directly, which I mark it. A vector which is parallel to the given line. That's the point. I am looking for the foot of the perpendicular q. I'm going to first write this equation in the parametric form. So x is equal to, I equate the I coefficients from both sides. So x is equal to 1 plus 2t. So that's going to be x is equal to 1 plus 2t, y is equal to minus 1 plus 3t, and z is equal to 2 plus t. This is actually any general point on the line. And if it is any general point on the line, we would say that let it be q. So let q be 1 plus 2t minus 1 plus 3t and 2 plus t. So that's the point q. So I know the 2 points p and q. So p is 1, 1, 3 and q is this. So I'm going to find vector pq. And vector pq will be oq minus op. So I write my oq point minus op point is this. Subtract them. So 1 plus 2t minus 1 is 2t, minus 1 plus 3t minus 1 is minus 2 plus 3t, 2 plus t minus 3 is minus 1 plus t. So that's PQ vector. Now we know that PQ is perpendicular on the line. So vector PQ is perpendicular to B vector. And so PQ is perpendicular to B vector. Therefore PQ dot B has to be equal to 0. So I will copy my PQ vector dot B vector now. PQ vector is minus 2t minus 2 plus 3t minus 1 plus t dot B vector is 2, 3, 1 is equal to 0. Now to take the dot product, we multiply the I coefficients together. So 2t into 2 is 4t. 3 into minus 2 plus 3t is, when you multiply, you will get minus 6 plus 9t. And then 1 into minus 1 plus t is minus 1 plus t is equal to 0. Then you add the like terms together. So you will get 14t is equal to 7. And so t is equal to half. So we found the value of t. This value of t, if we put back into q, I'll get foot of the perpendicular. Therefore, the foot of the perpendicular is, replace t by half. So 1 plus 2 into half. 1 plus 1. Minus 1 plus 3 into half. 3 by 2. 1.5. Minus 1 plus 1.5 and 2 plus half. 2 plus 0.5. Which gives me 2.5 and 2.5. That's the point Q, which I'll mark here. And then the next question is to find out the shortest distance between P and Q. So the shortest distance PQ will be root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. I mark one of them as x1, y1 is z1, the other as x2 minus x2, y2, z2, and put it in the formula. So 1 minus 2 minus 1 square plus 1 minus 0.5, so 0.5 square, plus 3 minus 2.5, which is 0.5 square. 1 square is 1, 0.5 square is 0.25, 0.5 square is again 0.25, which is root of 1.5. So that's the foot of the perpendicular. An extension question which you could get on this is, they could also say, after they say find the foot of the perpendicular, also find the image point. Image point means like you treat the line as a mirror. So the image will be on the opposite side somewhere down here at equal distance. Like if P is the point, image will be some P dash here in such a way that PQ and P dash Q will be equal in length. So I will mark P dash here, call it as x1, y1 is z1, and then I'll say x1 plus x2 from here divided by 2 is the midpoint. Y1 from here plus y2 is 1 divided by 2 is equal to midpoints, y coordinate which is 0.5, and z2 from here plus 3 divided by 2 is equal to 2.5. Then I'll solve for that x1, y1 is z1, which will be the image point. That's a possible extension question on it.